Welcome to all. I am Usha Rani, Assistant Professor in the Department of CSBS in Ramco Institute of Technology. In this session, we are going to see the brute force technique, which is a subtopic of design and analysis of algorithms course. So, in this technique, uh, we are going to discuss some algorithms also. So what is brute force technique? A brute force algorithm is a simple, comprehensive search strategy that systematically explores every option until a problem's answer is discovered. It is a straightforward approach to solve a problem. So many examples are there in brute force technique. So here I am going to explain some of the examples: sequential search, selection sort, and string matching. So first one is sequential search. In sequential search, we are having set of numbers, and there is a number which is a search element. It may be present or it may not be present in the list. So we have to search one by one. So in sequential search, since it is a brute force technique, we are using the sequential search, right? There is no strategy in it. So first we have to compare the first element with the search element where it is not matching, right? So it will go for the next element and it will compare whether it is matching or not. So 4 is not 3, right? So it will go to the next element. 3 is equal to 3. So there is a match. So it will return the particular position. So this is how the sequential search is happening. So there is no strategy in it. But if it is some other algorithms like divide and conquer, uh, we, uh, we we know, right? So in divide and conquer, the total time complexity will be reduced by 2. Um, so in sequential search, we are having big O of n, but in binary search, we are having big O of log n, right? So that is efficient. So brute force technique is a basic technique, so in which we are systematically explores the every option until a problem's answer is discovered. So it is a basic technique. So next one is selection sort. In selection sort, you have to identify the minimum element. So the first minimum element will be placed in the first location. Then the next minimum is identified and located in the second position. Likewise, we are doing the selection sort. So this is also, there is no strategy, right? So how we are in real life, how without any effort, how we are sorting. So that is what the selection sort. So next one is the string matching. So string matching problem is we have to find whether the pattern is present at the text or not. So if it is present, we have to return the matched index. Otherwise, we have to return -1. That means there is no match. So what is text and what is pattern? So here the example is given. So text is hello gem, pattern is gem. So we have to find whether the gem is present in the text or not. So here the gem is present in the fifth location. So fifth location, because I'm considering the index starts from 0, so it is located in the fifth location, right? So here text is hello gem and pattern is gem. The matched index is 5. So this is an example. Now we are going to see the algorithm for this problem. So before that, we will convert this into a general form. So in this, the text starts from T0 to Tn minus 1. So here they are considering the length of the text is n. So they are starting the index from 0 to n minus 1. And in pattern, P0 to Pm minus 1. So the length of the pattern is considered as m. So the index starts from 0 to m minus 1. So text and pattern index always starts from 0. So m is always less than or equal to m must be less than or equal to n, right? So the pattern should be, length of the pattern should be less than the length of text. So this is a problem explanation. Next we will see the algorithm. So what is the input? The text and pattern is the input. The text length is n, so which starts from 0 to n minus 1, and the pattern length is m. So it starts from 0 to m minus 1. So what is the output? If the pattern is present in the text, means we have to return the index of first character in the text that starts a matching substring, right? Otherwise, we have to return minus 1. That is the output. So first loop, I starts from 0 to n minus m. So I starts from 0. We can consider this as a text loop, right? So in text we are having 0 to n minus 1 characters. So we are starting, that's why we are starting the index from 0. So till we have to search till n minus 1 m, right? So n minus m. Why we are subtracting this m means that is the length of the pattern. So till n minus m location itself we need to search, right? So next j equal to 0. So they are considering the pattern length in j. So j equal to 0. So while loop has to run until j reaches m. So that is pattern of length. So when it will run, so when the pattern is matched with the text, then we have to increase the index of the pattern. So p of j equal to text text I plus j, then it has to increase the pattern length. That's why if g is matching, then we have to check whether e is present in the next location or not, right? That's why we are incrementing j till it reaches m, right? So once the substring is matching with the text, then if it coming out of the while loop, it will be equal to m, right? So if j equal to m, it will return the I containing the location starting index of the substring, matching substring. Otherwise, if j is not equal to m, it will go to the next statement, that is return minus 1. So it means there is no match of pattern with the string, search string, right? So this is the algorithm. So now we will analyze the time complexity of this algorithm. So in the first in this algorithm we are having two loops, right? For loop and while loop. So aftermost loop is for loop, which will run up to n minus m times, including 0. We can consider this as n minus m plus 1. In the inner loop, it will run for m times, right? At most m times. So I am multiplying m into n minus m plus 1. So this number of times it may take, this number of iterations it may take. So next thing, we have to find the time complexity. In n minus m plus 1, always the m is a greater element. We all know that is the initial assumption we have discussed in this algorithm. So n is always greater, that is text length is always greater than pattern length. So we can consider n alone inside the brackets. So outside that we are having m. So m times n is the time complexity of string matching algorithm. So the time complexity is big O of m. So string matching algorithms useful in various applications. So here I have given some applications. First one is document matching. There are several documents. We have to find the matching documents. So in which each document is decomposed into string tokens. Then the string tokens are compared between the two documents, and the matching result will be given as document matching percentage, right? So that will be useful to fetch the relevant documents. Next application is spam detection. So similarly, now we will have a database of spam suspected keywords and test mails. So the algorithm will compare the spam suspected keywords in the test mail. So based on the keywords matching, it will detect whether it is a spam or not. So that is one of the application of string matching algorithm. So next one is bioinformatics and DNA sequencing. We may all study about DNA, right? So there are four proteins involved in DNA sequencing: adenine, guanine, cytosine, and thymine. So ACGT. So uh, these are all various combination of ACGT will form the protein, right? So in bioinformatics, if you find a sequence of protein, it will have specific strings of this DNA sequencing, right? So there we can use. So this is how we can find the DNA sequencing in bioinformatics. So these are all some examples of string matching algorithm, and it has more applications. Thank you.